For question number 3, you know that we have a cardioid, 3 plus 3 cosine theta. We know it's symmetric over the x-axis. We also know that we will have to sweep through 0 to 2 pi radians in order to come up with the entire cardioid. So what I'm going to do is I'm going to use symmetry. I'm just going to go between 0 and pi, and I'm going to just take 2 of those regions. So I have 2 times 1/2 this whole thing. Personally, I would like to factor a 3 out of this. So we're going between 0 and pi. And I'm going to think of this as 3 times 1 plus cosine theta, quantity squared. So this really is going to be a 9, so I'm going to pull a 9 outside. We go from 0 to pi, and that's just going to give us 1 plus cosine theta squared. So 1 plus 2 cosine theta plus cosine squared theta, d theta. Again, cosine squared is going to give me a little bit of a problem, so I'm going to replace that. So I'm going between 0 to pi, and I'm going to have 1 plus 2 cosine theta, and then I'm going to have plus 1/2 1 plus cosine of 2 theta. And I might regret having done this, d theta. All right, so I'm just going to take the antiderivative of, let's see, I'm going to distribute this 1/2. So 1/2 plus 1/2. All right, so we have 3 halves in here. So we have 9. The antiderivative of 3 over 2 is 3 over 2 theta. The antiderivative of 2 cosine theta is 2 sine theta. The antiderivative of 1/2 cosine 2 theta is going to be 1/4 sine 2 theta. And we're looking at this between 0 and pi. Okay, well, what I know is that if I plug a pi in, sine of pi is 0. So that's going to give me 0 for these two. So I'm just going to have 3/2 of pi. If I plug a 0 in, that's going to give me 0 all around. So my total area is just going to be 27 pi over 2.